Okay, today we're going into chapter 6. This chapter is very important for your testing. Hmm. So chapter 6, we already done. Chapter 5 already done acid and alkali, or acid or base. We just look at H plus and OH negative. Today we'll look at how we balance equation, right? How we balance equation. So this is part of the important chapter for your final and also chapter 2. With this, I write something on the whiteboard. So A plus B, then you will go. Sometimes you will have double arrow, means it can reversible. So this part is input. This part is your output. Okay. So today our chapter will focus on how you calculate the small a, small b means the coefficient for the reactant, right? So this small a, b, c, d is actually mole, in mole. This a, b, c, d, they are in mole. Okay. So the first word, equilibrium. Equilibrium means become the same. So in chemistry, we look at either temperature or the reaction has been stopped, means the exchange of reaction has been stopped. Okay, so this is the word means equilibrium that we have. We are very familiar in your chemistry 1 or in your other physics. Okay, means if it's in equilibrium, means they have reached sameness of the surrounding. So for example, the diagram on the screen here, when the water you put in the environment of 25 degrees C and you leave it for some time, the temperature will reach at 25 degrees C, means we already reach equilibrium. Okay, okay? So so same with your body temperature also. Your body temperature is keep adjusting so that it always maintain 36 degrees C or 35 degrees C. Okay, definition. A reaction rate or rate of a chemical reaction. So when you see the word rate, R-A-T-E, it means something must be divided by time, right? Something must be divided by time. So it's a measurement of how fast the reaction can be happen, right? So in the chemistry 2, reaction rate means the amount of reactant that changes the product in a given periodic time. Means the right on the whiteboard here means A, B have to change to C and D. So how many mole of A and B have been changed to how many mole of C and D? Okay. So this is when you take sulfuric acid and you pour inside sucrose. So this is sucrose means sugar. You pour acid and sugar, so the reaction will happen. So this one is before the experiment. This is after the reaction. In the middle means 15 seconds. You'll see some reaction happen and you observe some black color happen, means it become oxidized. And then after 1 minute or 60 seconds, you see that there's a pile of black carbon was observed in the experiment. So in all kind of experiment, not only in chemistry, but in physics or in statics that you learn in your degree later, you always need a control medium. With in this case, the beaker on the right hand side. You always need something to compare. Huh? So when you do research, when you do lab report, or when you go into degree, you do research later, you need to always have a control sample. So you always same. This is for chemistry. This another one is the luminate light stick. So you can see when you when you bend it, the chemical will mix, and then you'll see the luminance of the light. Okay. Okay. So this is the very important definition for reaction rate, which is amount of product that form in a given period of time. Okay. So product means this one, output. Here, product means how many product was formed at a period, some period of time. Okay. Okay, so this is just an illustration, periodic illustration on a periodic table. On the top is fast rate, on the below is slow rate. Fast rate means the reaction happen very, very fast. As you can see, your x-axis is time, and if you mix the red color and the blue color, the product will be the green color. So if you see the diagram, the first one on the far left, you mix two reactants, and then some reaction happen when you see the green color. So if it's 100% have been converted into green color, means the reaction have been completed, right? Or reach equilibrium scenario. The below one is the slow rate. Slow rate means you mix the purple color plus a yellow color and you have a chocolate color. It will take some time to reach to see the chocolate color, which is in the third box here. This is comparison between fast rate and slow rate. So it's important you mention this one in your lab report later, right? So in this one is some application of the rate of propellant or rate of reactant, which is here is when you design a rocket, you light it up, and then the reactant will happen, the reaction will happen. So you'll burn, and then generate power or generate force. So this is just an application of rate of reaction. Okay, so this is a video how you make a hydrogen fuel mini rocket, an experiment. If we have time, then we'll do this one. If no time, then this is just a video for you guys. All right. So it just means that this is a plastic bottle that that you can buy from the market, the ink drip, the ink sucker or something, and you cut the mouth. Then you do some mixture of A plus B, you get oxygen. Then you fill the oxygen here, right? And you just light it up with the bottle, right? Let's have a. So this one is about 8 minutes, so you watch it when you're free. You go to my PowerPoint slide later, you click, and then you watch the video. Yeah? Okay. So we straight go into what we're going to see in your test. Yeah. So there will be one question asked you in test 2 later on, which is you need to explain the rate of reaction using collision theory. Collision theory means two things hit each other and then reaction happen. Yeah? So there will be one question asked you about this slide in test 2 and also final exam. So what is collision theory in chemistry 2 or related to chemistry reaction? So when there is a chemical reaction, collision between molecules happen, right? there is a collision between molecule or atoms. Okay, so it means collision theory means when does the chemical reaction happen? So when there is a collision between molecule and molecule, or molecule atom, or atom with atoms, then chemistry reaction happen according to collision theory. So for example, the one on the left here, you have NO3, and if these two molecules, NO3, they collide each other, right? And once they collide, if the output is the same, then no product happen, means no reaction happen. Okay, they collide, but the output is the same like the previous one, means no reaction happen. However, this one, so this one, if the collision not properly oriented, means the molecule not properly oriented, they hit each other, and because of the angle, like Lego bricks, you're not able to match each other, then reaction won't happen. But if they are oriented nicely, like the one below on the left down here, so NO3 plus NO3, when they collide, they mix each other like Lego bricks. Nitrogen and nitrogen meet each other, exchange electron valence, then you'll form N2O2 products. This is means bonding formation. We learned about bonding in your chapter 1 already, right? So like the one on the right here, it means that if you see CO and O2, they collide, but if there's no product come out, means no reaction. The one below here, CO and O2, when they collide, and there's a CO2 formation, means reaction happen. Chemical reaction happen. So basically, if the question asks you, use collision theory to explain chemical reaction, basically, you just memorize these two sentences here. Okay, you just mention, according to collision theory, chemical reaction happen through collision between molecule and atoms. Okay, so sometimes the question will ask you to draw something to explain. Okay, you can either use the one that I show on the slide here, or this one. Okay, so actually it's the same, because in exam you don't have color, so you just represent with white color and black color. Okay, so if we take gas phrases, we take H2 and I2, you mix them, will form HI, gas form, right? So if they see the question to explain reactant A plus reactant B will form reactant C, so the step will be the same. The step will be the same. So first step, what you write? You write, consider gas phase chemical. You just, this one you copy the question. Means you consider the gas phase chemical reaction between product A gas and product B gas to to form product gas C. Then you write the chemical reaction. Only one way, only one way arrow, one way. So H2 plus I2, remember after chapter 5, you need to write the state of the reactant. So in this case, you are having gas. So you bracket G. In chapter 5, acid and alkali usually is AQ, aqua. So and then water, H2O, is also liquid. So in chapter 6, normally you will see gas. Okay. So then you start to write this one. The reaction begins when an A molecule collides. The keyword we want to see, if the question asks you to explain with collision theory, you need to use the word collide in your answer. You need to say A molecule collide with B molecule. Then you'll get marks already. Okay. Then this is explanation. Sometimes the question asks you to illustrate your answers with a diagram, or draw a figure to illustrate your answer. So this is the one that I expect lah. Okay, so you draw two. One is white color with the represent H2 plus I2 with the black color, two circle. First one, you tell the lecturer or the markers that what happened if there's no reaction. No reaction means you will still see the two white, two black, means you still seeing the H2 and I2. Means no reaction. And as you can see on the screen here, why there's no reaction, improper, you need to write, improper orientation for the diagram on the top here. You need to write this one. On the top, improper orientation, like Lego bricks. If you're unable to orientate correctly, you are unable to join the Lego bricks. So this is also the same. And then you need to explain. Collision happened because of not enough energy or insufficient energy. So they will bounce off each other. Means they do not join together. They do not form products. So once you explain the no reaction, you need to explain based on collision theory, what is the reaction happen. So you draw again, two white circle, then below there you write H2 plus the two black circle, you under there, under the black two circle, you write I2 or B reactant that mentioned in the question. And you need to highlight the arrow here, which is the proper orientation. Proper orientation, you need to adjust it. You need to adjust it. Yeah, the LCD a bit blur, but I hope you can still read it. Better. Okay, so the second one, when collision happen with enough energy, beside the same the correct orientation or proper orientation, you need to give enough energy. The the colliding molecules are moving fast enough, and the reaction can proceed to form a product. Means the keyword there, the reaction based on collision theory, you must use the word collide, and then energy, mention proper orientation. Then you must mention what is the end result. The end result is to form a product. Yeah. So reaction, it must be based on collision theory. Yeah. You must mention energy, orientation, and the products was formed. Okay. These are the three keywords. And then with the correct diagram. So this basically is how you will see in your test 2 and final exam. The question will ask you, explain the reaction, chemical reaction happen between A and B using collision theory. Basically, it's just the same like these slides, but you change the element on the slides. Okay. So just some understanding here. If you have enough energy during the collision, you will lead to product, means product will form. If not enough energy or low energy collision, it will not. Means the reaction won't have, product won't happen. Yeah. Okay. This one you read. Okay. This is important. What will influence the rate of reaction? What will influence? There are two: concentration of the molecule, which is concentration that you learned in the previous chapter, which is you use a bracket, which is in mole per liter or mole, something like that. Concentration. So no matter no matter what question you face in the chemistry 2, you need to know how to use the mole or convert something parameter back to mole. Then from there you answer the question. Second, temperature. Okay. second temperature. There are two factors that influence the reaction. So sometimes the question, especially come to final exam, it will ask you, what factor will influence the rate of reaction? Basically, these are the two that we're looking for in your answer. With this concentration of the reacting molecule, concentration of the reacting molecule, and temperature of the reacting mixture, a reaction mixture. One's referring to the molecule, reactant molecule, and the one is the temperature of the mixture. The temperature of the mixture means energy. The higher temperature you have, more energy you have, means you'll come in a very high speed collision. Okay? So this again is a same repeating the same ideas. So if you take H2 plus I2, you'll form 2Hi. So if you have a low concentration, it will be like this, like A. B, have more concentration means molecule inside the container. High molecule means you have more and more molecule, related molecule. Huh? Okay. So from here, which reaction mixture, A, B, C, will have the fastest initial rate? C, yeah? Yeah? Okay, mixture C have the fastest because have the highest concentration. There are only two factors, concentration and temperature. Concentration of the reactant molecule and temperature of the reaction mixture. There are two factors. Okay. Okay. So this is just a principle. Rate of chemistry reaction will increase with increasing concentration of the reactant. Okay. So calculation for reaction is out of chemistry 2 chapter. Means I won't ask you how many concentration that you need to form or something, but the idea is there. I will ask you collision theory, explain rate of reaction. Okay, there will be one question come out. Huh? So, okay. Second one, can you explain why chemical reactions slow down as more product is formed? Okay, during the reaction process. Why? Again, there are two factors affecting the rate of reaction. Concentration. Concentration of what? Of the reacting molecule and temperature of a mixture. Right? So here, this question. Why the chemical reaction slow down as more product is formed? Why? Yeah. Why when you get the product over this side, why the reaction slow down? Why? Because the concentration of reacting molecule become less and less. Yeah, the only two factors that reacting the rate of reaction, concentration of the reacting molecule, and also temperature of the mixture. So this question actually asks you back to the two factors just now. This is because of the concentration of the reacting molecule has been reduced during the process. Okay. So this is the answer. Concentration decrease during the process. So it will affect the reaction. Okay. So up to now, we have covered collision theory. You should be able to explain what is collision theory. Basically, you think of Lego bricks. Two Lego bricks join together, orientation different, cannot join, no products. If you join, it must come with a very high speed or very high energy. Come with high energy, correct orientation, then product will happen. Okay? So basically, this is then two factor, concentration of the mixing molecule, reacting molecule, and also temperature of the mixture. Two things only. Okay? Okay, so this was the graph if you do experiment. Y-axis is number of molecule. So we have two lines here, the blue line and the red line. Red line means is the product. Blue line is the reactant of A. So as you have more and more time pass by, the reactant will reduce, the product will increase. This is what you can measure in the experiment. Now, just now we keep focusing on concentration. Now, we need to answer how temperature affect the rate of reaction, right? So same tree diagram here. You have low temperature, means low energy. The Lego bricks will come in very, very slow. Intermediate, okay, medium speed. And high temperature will come in very, very high speed like highway, right? Okay, so this one, which reaction mixture will have the fastest initial rate? So of course, it's a highest temperature or high temperature scenario. Yeah. Okay. Rising temperature, it means you have more energy. More energy means molecule move faster. So if you have move faster, means more collision per unit time. Means you have a loss of temperature, a loss of energy means inside the same container, more molecule will collide each other very, very fast, right? So if you have high temperature or high temperature means more energy, more collision per unit time will give you faster reaction time. Higher temperature will give you higher energy, will also give you faster rate. Reaction will mean faster, right? So it just basically, this slide means temperature equal to energy. If you have higher temperature, molecule move faster. When the molecule move faster, then faster reaction rate. Okay? Okay, so again, collision theory, only focusing on the rate of reaction. Two factors that affect the rate of reaction, which is concentration of the reactive molecule and the temperature of the mixture. So you need to give me full answer. One, you explain about the concentration, and then you explain about the temperature. Okay? So roughly about 10 marks for collision theory. So 10 marks is about 5 marks on the left, 5 marks on the right. So it's about here you explain with the diagram. Here also you explain with the diagram, right? Means two diagram we expected. No reaction. What mean by no reaction? What mean by there's a product happen, there's a reaction happen, and so on. Yeah. Okay. So this is another one, right? So this is another one. So just now, collision theory is this one. The rate of chemistry reaction increase with increasing concentration. This is the first sentence that explain about the concentration. Second sentence we're looking at is the temperature, which is this one. Rate of chemistry reaction generally increase with increasing temperature of the reaction mixture, right? So basically these two things, right on the whiteboard here. We keep repeating the same thing for the past 10 minutes. Yeah. Okay. To summarize. Sorry. To summarize, these are the key points that we keep repeating. First, reaction rate increase with reactant concentration and also temperature. The higher temperature you have, the more reaction rate you have. And reaction rate generally decrease as the reaction proceed. Means the reaction will slow down, as your reaction happen. Okay, so while reaction proceed and reaction will slow down, it's because the concentration of the reactant was reduced. Okay, and then some reaction that it will also affect the temperature, but generally you only need to mention these 3 points is enough. Okay. Okay, so this is just a fast, quick quiz. In chemistry reaction between two gases, again is a gas form, what would you expect to be the result of increasing the pressure of gases? Okay, it give you 3. Increase in react. So what would be the expected scenario? Will the reaction rate increase or decrease or no effect? Why increase? Yes. Okay. So it's more increase. Okay. Now we start some calculation. We start to introduce you what is dynamic chemistry equilibrium. Dynamic means in the motion, it keep on changing. Right? Now, just now you see single arrow. If you see double arrow, means there is a dynamic action happen, means it can reversible. It can form H2 plus I2 form 2HI, but there's a double arrow, means 2HI can be back to H2 and I2. So this is we just again mention what is the double arrow means. It means it's a reversible reaction. Okay, it's a reversible reaction. Okay. Okay, so this is the application of the collision theory. It means that H2 plus I2 to form the product HI. H2 and I2 need to collide in the correct orientation and high energy. And to form H2I2, HI products need to collide each other with very high energy and proper orientation. I need to use the word proper, not correct. Okay? Proper orientation. Okay. So if you have a double arrow like this, reversible, means there are 2 reactions possible. A plus B will go to C and D, and also it can be CD back to A and B. Okay. And then you need to know how to start to use reactants and products. Need to know how to use the word reactant and product. These 2 words. Reactant, if you put on the left, it means you start from that side. So reactant, if you put on the left, means A plus B will go to CD. If you put CD as a reactant, CD will go to the product. It will form products. Yeah. So suppose we begin with 2 elements, H2I2 again, in a container, and it's a reversible reaction. What happened initially? So you can see there's 4 diagrams there. And as the time move from the left to right, it was diagram A will have 8 mole of H2, 8 mole of I2, and 0 mole of HI. B will form, B will be some product will going to happen. 4 HI has been formed. Okay, the number of molecule must be same or atom must be same. 8H2 means you got 16H. 16H. 8HI2 means you got 16I. If you move from the first diagram into two diagram, the total number must also same. 6H2 means 12 plus 4H means still 16. 16H. Same with the I. I6I2 means you have 12I plus 4I here, the second diagram. So more and more products form. As you can see there, more and more product form. Diagram number C and number D, C and D actually is the same. When CD same means it reach equilibrium. Okay. So initially, if you look at the diagram, it means that H2, I2 will collide and form HI. Okay. And then when it reaches a certain stage, it will reverse back. Okay. It reaches a certain stage, it will reform back. Reform back. Okay. This one is you read equilibrium. What does it mean? Means the product is the same. It means it's reversible, although it's reversible, but the concentration is the same. Okay. So means diagram C, it might be HI, H2I2 to HI. However, when it comes to D, it can be from the HI to H2I2. But the rate, the concentration is the same. Right? So one part of the question will ask you, how do you know equilibrium has been reached in a chemical reaction? So you need to put this word. When concentration of the reactant and product. So again, chapter 6, reactant and product is a very important keyword. When concentration of reactant and product no longer change, equilibrium reach. Okay. So reactant of this one important. Concentration is important in reaction. So sometimes the question asks you about this one, right? So when the question asks you, what is dynamic equilibrium? It means dynamic equilibrium, it asks you, it expects you to write rate of forward reaction equal to the rate of reverse reaction. The light blue means the keyword that we are looking for. Once you need to explain what is forward. Forward means move from the left to right. Or forward reaction, sometimes it also means reactant to product, means reactant into product, forward. And sometimes reverse reaction means product back to reactant. Okay. Okay. So why we use dynamic and not static equilibrium? Because the reaction still happening. It continue to happen. This process continue to happen. That's why it cannot use static equilibrium. Static means do not move. But this one continue to change. Okay. So this one you read, basically, if you understand what is dynamic equilibrium. So this one is important. Another miss or another careless mistakes. No longer change in equilibrium does not mean that the concentration of reactant and product are equal to one another at equilibrium. It means this small number here. This A, B, C, D do not like balance. It's not like 4 here. No. It doesn't mean that. It means that the forward reactant to forward reaction, reactant to product, is the same as product to reactant. This one, this definition, this one, equilibrium. The rate is the same. The rate, we are looking at the rate of the reaction is the same. Forward and reverse is the same in dynamic equilibrium. Yeah. Okay, this is just a summary, useful for your revision for your test 2 and so on and exam. It's just the point that we highlight just now. Right? Okay. Okay, how do we measure how fast? How we know that fast or slow the reaction from reactant to product or product to reactant? Okay, we use a mathematic model which is called equilibrium constant KEQ. This one will come out in your test too. This one sure will calculate on. So this one will come out. Okay, so I give you a general equation first. Right? So small a, big A plus small b, capital B, and then there's a reversible reaction. C to capital C plus D and capital D. So this is what I write on the whiteboard just now. Okay, the small b, a small alphabet, the blue color means concentration, which is in mole. Which is in mole. The yellow color, capital A, capital B, capital C, capital D, it means reactant and product. The one on the left, it means reactant. The one on the right, C and D means product. Okay. Then the sky blue color, small a, small b, small c, small d is a coefficient, stoichiometric coefficient, or in the unit of mole. Okay. Remember this formula? You need to write KEQ equilibrium, K, capital K, EQ equal to, you need to write the bracket in the test. Capital bracket means the mole or concentration, and then C, and then D, and then A, B below there, with a small alphabet at the corner of the equation. Yeah, so the small CD, A, B, C, D, the small capital, it means what you see from the stoichiometric equation. You just copy and put it there. However, the CD, the capital C, D, A, B is the concentration. You need to calculate. You need to calculate by gram and also the molecular weight number. Right? So I will show you how to do. Okay. So again, in the test, if the question asks you to calculate the rate of reaction, you need to write the general equation. You need to write this one out. The colorful A, small a, capital A plus blah, 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 until the CD. You need to write this one, and then give me the K equation. Okay, this pair come with 2 marks. Okay, if you miss this one, then you suddenly give me an answer or put question mark how you calculate. Yeah, it's a free mark. Memorize this equation. It won't be given in the test or final exam. It's just a bonus mark. This one sure come out on. Important. Okay, now how we use. Like for example, this is a very simple equation. Just now, the ABCD means there are 2 reactant. If you do not see the reactant, let's say you don't have B, you just don't need to write B. Don't need to write B, don't need to write the red color B in the equation later when you substitute the number. You just single it out. You just take it out. Yeah? Okay, like this equation. 2NO, N2O2 gas. Reversible process. 4NO2 gas and O2. So again, you copy this equation in the test, and then you write the general equation. You know that this is small a, this is capital A, no more reactant, B don't have. 4 is a small c, NO2 is the capital C, plus O in front, there's nothing, means 1. Okay, this is small d and capital D. So how we calculate? Again, write this equation in your answer and write this KQ equal to this equation. Okay, then you substitute. After you write this one, substitute the value, you write KEQ equal to bracket NO2 bracket 4 bracket O2 bracket 1 divided by bracket N2O5 bracket 2. Okay. Okay, we go into exercise. Go to an exercise. So write the equilibrium expression of the chemical equation. So if you have CO gas, or still good. Chapter 6, most of the time you see gas. If it's in the question, you see gas state means is a chapter 6 question. So CO gas, 2H2 gas become CH3OH gas. So write the equilibrium expression. It means write KEQ equal to CD divided by AB. Okay. So first solution, write this one again. All right, small a, capital A, blah, blah, blah. I write this equation. And then write the KEQ bracket CD divided by AB. This one will cost you 2 marks. If you write this one, you'll get the 3 mark, 2 mark already. Even though you don't know how to substitute later, but you write this one, you get 2 marks. And then you write this one. Okay. We haven't substitute yet, but later chapter you'll see numbers there. At the current chapter, we just write like this first. Okay. Yeah. So this one I think quite straightforward. Nothing complex here. Here. Sure. Okay. Yeah. Brian again. Okay. Second one also same. You should be able to see this is A, this is B, this is C. No D, so you just no need to write the D. Okay. This is just exercise lah. Nothing there. Okay, equilibrium expression. We just write in the CD divided by AB. Remember the small capital. Remember to write the small capital. In the test or final exam, there is a value for small a, small b, small c, small d. Don't forget. Okay. Okay. So just now you know how to write this one already. So why does this constant tell us? Okay. Okay. So if you get a number later in the real scenario, if you get CD divided by AB, you get more than 1. It means it's a forward reaction. Means it moves from the left to right, from reactant into product. Okay. So there will be more product than reactants when equilibrium is reached. So just now you know how to arrange the KEQ already. Later I'll give you a question, you calculate, you will get more than 1. If you get more than 1, it means that forward reaction happened. Or you write possible, very high possibility forward reaction will happen in this process. There will be more product than reactant when equilibrium is reached. So if you get a number more than 1, you tell me what does more than 1 mean. If more than 1 means even you see this arrow, the double arrow there means it moves to the left to right. So something must be happen. So first direction of reaction, you tell direction of reaction from forward reaction. And then when there's a forward reaction, more product then the reactant will happen. This is how you answer in your tax and final exam. Yeah? When equilibrium is reached, you need to state the situation. Yeah? Equilibrium. More than one means forward. Okay, reactant more than the product. Sorry, product more than the reactant. Okay. All right. Now, if you get a number, let's say I just simply, when you calculate later, you get a number 1.9, 10 power 19 at 25 degrees C. What does it mean? It means more than 1 means this process, if this process has to BR2 and give you this EQ number more than 1, it means it's a forward process and the product of HBr were more than the reactant. That is the thing lah. Okay. Far to the right means forward direction, left to right. Okay. So less than 1 is a reverse, means reverse lah, opposite from what you learned just now lah. Okay. So you only need to remember more than 1. What happened? If less than 1 is the opposite meaning of more than 1. Okay. So basically, it's a reverse reaction or forward reaction. More than 1, forward. Less than 1, reverse, or following the double arrow direction. Then the question will sometimes ask you to predict whether there is more product or more reactant when equilibrium reach. You use EQ value, KEQ value. Okay. So this is the same, it's the same. Again, some of you, your mathematics is quite weak. What I mean by more than 1 and less than 1? Remember on the negative number, index number there. If it's positive, means very big number. If you have 10 power negative something, means less than 1. Less than 1 means it's a reverse reaction already. Yeah. So again, if it is very, very small, if it's very small number, sorry, small number is very small, meaning at equilibrium, lies far to the left, high concentration. Yeah, it's very small, less than 1. Okay. Yeah. Yeah. So this one, the bracket means in the question, it will tell you how many mole. Like for example, in the question, for example, 0.1 ml, 10 capital M. How many more in this question? I give you reactant A lah. 0.1 ml, 10 capital M. This one, capital M means what? Mole per liter. So to want to get more, what you do? 0.1 multiply 10 mole. This is ml. This is 1,000 liter. Right? Liter, mole per liter. So you press calculator, it will be how many? This is 0.001. So it will be 0.001 mole right? So this one, if this one A, you put inside here. Then you use calculator, exponential that number. Yeah. Yeah, I think we stop here. It's here. Okay, be careful on the equation KEQ. You can see KEQ only works on gas. For example, this one, got solid one. In a reaction, you will form solid. So when you write KEQ, you cannot write like the one you see on the slide here. Means the carbon bracket S, you cannot write in the D here. Okay. So why? Because solid concentration do not change. If it's in solid, cannot change one. Only gas can change concentration. Right? So it means you adding more or less carbon to the reaction mixture doesn't change the concentration of carbon. Right? It's already solid already. No matter how many reactant you add, it's already solid. Yeah? So concentration of solid depend only on density, but it is not applied here. Cannot use. So in the KEQ, if you see this equation with the solid, you do not calculate solid. You just take out the solid and calculate the gas only. Yeah, I show you the careless mistakes here already. It's just a reminder of your chemistry 2. Solid do not include in the KEQ equation. The rest you write, the rest you just read through. It will be the same process. Another one also, liquid doesn't apply also. Just now solid, right? In this equation, H2O is a liquid. Liquid also does not change. Pure liquid does not change. So solid and liquid does not change. So don't write in the EQ equation. Just don't write inside the equation. You just no need to write. Like for example, in this KEQ, you don't write the B inside. The B is not inside. You don't need to write H2O. Okay? The rest you read lah. So again, this just to show you, if there is a solid, you don't need to write solid lah. Means A, you don't need to write. B, you don't need to write. C, you don't need to write. You only write D. This one we continue lah. 6.6, we continue that next lecture. Okay. Stop here.